Hello, everyone. In this video, what I'm going to be talking about is model building within the common fate latent variable model. And so I'm going to walk you through my process and how I build my common fate models. Some of this is going to be a brief review of other videos, such as the baseline common fate and the common fate with distinguishable or indistinguishable dyads, and then how I build in covariates. And so where I'm going to start is just at the baseline common fate model. This is the first thing that I'm doing every time I want to run a common fate analysis. So I load my packages. I'm only using Haven and Lavaan. And then what I'm going to be doing is just running this common fate model, because I just want to get a sense of how well the model is replicating the characteristics of the data. Because if I have a really poor fitting common fate model from the start, I don't want to just all of a sudden just go into a mediational model with 5 or 10 different covariates when in reality the original model didn't fit all that well. That's something I want to know before I just kind of jump to my final model. And so what I'm going to do is just run this very base common fate model, and I'll open up the syntax. Again, this is identical syntax to previous videos and identical output to previous videos. But I'm just going to be talking again about how well this model fits. And so as you can see, the degrees of freedom and the chi-square is really low. CFI and TLI are at the max value. SRMR is good. RMSEA is good. Again, RMSEA tends to be either 0 or like 0.10 in small degree of freedom models. So it's either extremely cooperative or it's completely rebellious. And so I'm also getting a sense of the parameter estimates and the effect sizes. So again, pretty strong effect size here. And again, just looking at model variance accounted for, all of these things, I'm just kind of getting a good sense of what is going on in my model. So again, I generally have a good sense of what's happening here, looking at the regressions, the R squared, and the factor loadings. And the model data fit. Those are kind of the 4 things that I really kind of look at. I kind of monitor other things, such as like the covariances, but that's not to me as important early on in this process. So what I'm going to do next is, since I'm satisfied with the common fate model, I'm going to move on to test distinguishability. If I was not satisfied with the common fate model, I might switch over to an APIM, for example, because it might be that the factor loadings are below that 0.70 cutoff that is proposed by Lederman and Kenny in 2012 in their paper. And so I might say, okay, there's just not enough common variation between dyad members to use a common fate model. Maybe an actor-partner interdependence model is actually the better way to go. But since I do have a good fitting model, and I do have a theoretical rationale for testing the common fate over the APIM, what I'm going to do next is I'm going to test distinguishability at this point. So again, I go over distinguishability in a previous video, but very briefly, it's the exact same common fate model as above at the structural portion, at the latent variable portion. The only major difference is that I'm imposing 3 additional restrictions. Those residual covariances between male and female reporter are going to be constrained to equality, and the item intercepts within a given common fate latent variable are going to be constrained to equality. So the male and female intercept for CSI, which is relationship satisfaction or relationship quality, are constrained to be equal. Same thing with relationship mindfulness. All right, those item intercepts are going to be constrained to be equal across male and female dyads. If your likelihood ratio test, because this model that tests distinguishability is nested within this larger model. This is just a more restricted version. So you're going to have 3 additional degrees of freedom. If that chi-square difference test, or that likelihood ratio test, which I am measuring or assessing, I should say, right here, is significantly different, then you know you have distinguishable dyads, and that imposing those three constraints significantly harms the model. But if you don't, and that chi-squared or that likelihood ratio test is not significantly different, then you know that you have indistinguishable dyads. So even though from a theoretical lens, you might say men and women are different in their levels of relationship mindfulness and relationship quality, the data are not supporting that. And so they are empirically indistinguishable, which actually gives you more statistical power in most cases. All right, so we're going to go ahead and run that, and we're going to see to what extent our dyads are distinguishable or indistinguishable. So again, what I'm going to be doing is checking the model data fit from the user model. This is the baseline model. You can kind of ignore that. What that is you give everything a mean and a variance, but you don't give any of the variables any covariances. So they're just kind of sitting there in a model, presuming that there's no association or no correlation between them. And obviously that should be an absolutely terrible fitting model. If it's not, then you have much bigger problems. All right, so I'm looking at the CFI, I'm looking at the RMSEA, it's still cooperating, SRMR, everything's looking good. My model data fit's looking fine. So again, just kind of scouting out the parameter estimates of the factor loadings. You're going to see very small differences in this model compared to the baseline model because we are constraining those covariances or those residual covariances, I should say, across male and females to be equal. So that's going to affect your parameter estimates and your factor loadings, because SEM is a systems of equation modeling procedure where you tinker around in one area of the model. It's going to have either very, very large, moderate, or even quite small implications in other areas of the model. Okay, so we see this was 0.405 in the previous in the baseline model. Now it's 0.406. So again, you'll see very minor changes, but again, that's to be expected. The major takeaway is that the chi-square difference test is not significant. So we add 3 additional constraints to the model. So those are our 3 degrees of freedom, our 2 intercepts, and our 1 covariance. And this is our chi-square. So when you implement these restrictions, your chi-square is always, always, always going to go up. Your CFI, your TLI, your RMSEA, not always are they going to move. They could move in either direction depending on what those restrictions do to the model, but your chi-square will always go up, right? And so it's not insignificant. So that means we have indistinguishable dyad numbers, which means that we actually have more statistical power than we perhaps thought, and we don't need to actually remove the constraints that we placed in the model. Instead, we're going to use this model and then move forward into subsequent analyses. Right? And so in this first subsequent analysis, scroll down right here. All right, so you'll see that we have our baseline common fate syntax, and you'll notice the only thing I did is I added in some covariates. All right, whoops. Let's go to this model first, CFM1, my apologies. So we're adding in a between dyad covariate. So a between dyad covariate is a variable where you are going to have the same value for both dyad members within a given dyad, but the level of that variable or the value of that variable will differ across different dyads. Okay, so children is a nice example. So the couple has 2 children together, which means you're going to have a 2 for both males and females within a single dyad. But some couples have no children. Some couples have 1, 2, 3, 4, 5, 6, 7, all the way up to n children. And so we're going to look at the dyad to dyad differences on whether or not the number of children influences how satisfied or how happy these dyad members are, right? And so we're going to go ahead and we're going to run this model. And so we'll open up the syntax. So you'll notice that my primary research question is really about the what I ran in the baseline model. That is what I'm fundamentally interested in. And now I'm beginning to add in those covariates to parcel out the variance associated with those covariates, so I can better understand the unique contributions of, in my case, relationship mindfulness on relationship satisfaction. So how mindful the dyad is communicates with one another, and how does that impact how happy the dyad is. All right. And so I think my guess would be is I would say theoretically that having more and more children adds more stress to the relationship. The parents are perhaps having quicker conversations with one another, or they don't communicate even as often because they are, one parent's dealing with one child, another parent's dealing with the other child, and things of that nature. All right. So for a variety of reasons that we would probably want to parcel out the contributions of the number of children that the dyad has. And so what we see here is that the contribution of children has a very, very small and non-significant effect size. So the regression coefficient is 0.04. So that means for every one standard deviation. I don't really know what that means in terms of children. Here's where I would use partially standardized measures. But one standard deviation increase in the number of children leads to a 0.04 standard deviation unit increase, actually, in relationship satisfaction. All right. So again, kind of an odd interpretation, but it's non-significant, and it's the p-value is 0.54. So now that I've added in my first covariate, I kind of know what the effect size is. I kind of know what the variables are. I see that this has changed a little bit. So the addition of children has made this go up. This was at 0.045 and 0.046 in the first two models. So that's something that I'm kind of paying attention to. All right. Because as I add in more and more variables, if I start seeing these estimates getting really out of whack, then that tells me I might have some suppression going on. Perhaps there's something going along the lines of multicollinearity. So this is why I'm building my model kind of essentially one set of covariates at a time. It's kind of like when you do a stepwise regression, it's kind of in that same vein. Not necessarily, I'm not adding them in or taking them out based on significance, but what I am doing is I want to understand what my model is doing when I add in these different variables, one step at a time. And just because children are significant or non-significant in their contribution doesn't mean I should remove them. In fact, I think would actually be bad practice to remove children based on non-significant findings, right? Because as you can see, this went up by 0.15 or 0.20 even. So that actually is potentially a meaningful finding. And I theoretically believe that the presence of children, or the number of children between dyads, might have an impact on how happy the couple is. So I want to keep this variable in the model, even if it is non-significant. And so again, I'm monitoring everything. I'm monitoring everything else as well. All right. And so what I'm going to do next is I'm going to add in another set of covariates. All right. So what I'm going to do here is add in ACEs. So the male and the female report of ACEs. So what I've done here is ACEs, each dyad numbers, individual experiences of ACEs in childhoods, predicting relationship quality along with children. Right? So I'm just adding in two new covariates. And then here I am actually going to be adding in some explicit covariances, because I want to know the extent to which relationship mindfulness, which is our independent variable that we're really interested in, covaries with the number of children and the number of ACEs. And then the syntax is kind of like a correlation matrix, right? So what I did is I just copied and pasted this. So you do that. You just change the plus sign to a tilde tilde for covariance, and you keep doing that until you get all of your variables kind of covariate with one another. Right. And so that's what I've done here is I'm covarying every independent variable and covariate with each other. All right. And so when we think about those variables, we differentiate them because IVs are things that we're theoretically motivated by, and those are the things we really think are important. And then our covariates are things that we want to control for to get a more precise estimate of the impact of our IV has on our DV. But statistically, they are all working in the exact same way. There is no statistical difference between how IVs and how covariates kind of show up in the model or affect the model or influence the model. We do that to theoretically distinguish what we're interested in versus what we think are potential confounders. All right. And so I'm going to go ahead and I'm going to run this model. All right. And what you could do is you could add each dyad member's A score one at a time and run an extra model. I think that's more than fine. If I'm going to run the model, if I'm going to include like individual level predictors, again, these are actually going to be what's called mixed predictors. So the A score is going to vary between both dyad members within a dyad. They could have the same score, but they could also have very different scores. And all of the males in the sample and all of the females in the sample are going to have different values, right? So when I'm adding in a mixed predictor or a mixed covariate, I'm going to add it in for both members at the exact same time, and I'm going to consider that a step. So I wouldn't add only the males in first, and then in a separate model add the females in first. I think that's perhaps an unnecessary step. It's not wrong in any way, shape, and form, but I prefer to add them in kind of at the same time. All right. And so we want to check our model. Again, it's still fitting really quite well. Again, we're adding degrees of freedom, so chi-square is going to keep going up and up and up. We just want to be sure that our CFI, our TLI are not getting substantially worse, that our RMSEA is behaving, and that our SRMR, again, isn't getting too high. And it looks like our model's still non-significant in terms of the chi-square. Our CFI is 0.993, which is still exceptionally high in comparison to the previous model's CFI. It's really not significantly worse depending on your delta CFI cutoff. Generally, it's used as 0.01 in the measurement invariance literature. And so again, this all signs indicate we have a really good fitting model here, and that the addition of the ACEs isn't really messing things up for us. All right, and so now we have the effect of ACEs on relationship qualities. So again, we're further isolating the effect of relationship mindfulness. We are now looking at the effect of relationship mindfulness on relationship quality at the dyad level beyond the contributions of children and each dyad member's ACE score. All right. And again, you can see that the value of relationship mindfulness is fluctuating as we would expect it to be. That means that the relationship mindfulness is sharing a little bit of variation or accounting for overlapping variance with these predictors, right? So that is kind of what is kind of happening. You can kind of view it as like overlapping circles, and every time you add in another predictor, you're pulling that circle a little further apart or you're moving it closer in, and there's going to be that small little overlap where relationship mindfulness and ACEs are accounting for the exact same variance, but then there's going to be unique variance for relationship mindfulness only, and that is unique to relationship quality, and the ACEs have a little bit of unique variance. However, it is exceptionally small and non-significant. Okay. Like less, it would be like 0.002, so like 2 thousandths of a 0.02% of the variance. So less than 1% of the variance. So it'd be exceptionally small and not all that meaningful. All right. And so again, here, what you could do, depending on kind of your own philosophy of model building, is you could actually begin to constrain the effects of ACEs and children on relationship quality. So just as I tested distinguishability in at the dyad level in the second step, you could actually constrain the effects of ACEs to be similar across male and females to see if you can get an even more parsimonious model. Again, they're both non-significant, so there's not a whole lot more you could do in terms of making like substantive contributions, but let's say for males it was significant and for women it wasn't significant, and then when you constrain them to be equal, it harms the model. That means you have moderation, right? And so that means that the effect of male ACEs on relationship quality is significantly stronger than the effect of female ACEs on relationship quality. So there are other theoretically meaningful questions that you can answer here. But in our example, because ACEs are not significant, you can certainly constrain them to get another degree of freedom, but it wouldn't be all that meaningful, and it would be more for model parsimony, more so than having a theoretically derived question around moderation. So you can do, again, a lot of increasingly fancy things within this model, and that's more falling into the hybrid actor-partner common fate models that Wickham and Mesa talk about in their 2019 or 2021, don't quote me on the year, article about hybrid models. But again, that's another thing that you could do in your model building strategy, is constrain these to equality. And likewise, you can constrain children to equality. All right. And so now I'm just going to add in yet another set of covariates. So I'm going to be adding in negative attributions. All right. So as you can see, my model building strategy is just adding in a block of covariates at a time, so I can, again, really understand what is happening in my model parameter estimates. Am I getting into multi-collinearity territory? Am I getting suppression? And just checking out how my model is behaving across these conditions that I'm creating. So I'll go ahead and I'll run this more updated model where I'm adding in, again, each dyad member's interpretations of the other's behavior. All right. And so here, again, we are checking our model data fit. And so it's still non-significant, which means we still have a really good fitting model. Again, it's trending towards significance. So as we're getting more and more degrees of freedom, as we're adding more and more variables to the model, it's not surprising that this p-value is going down and down and down and down. All right. Our baseline models, again, still, you're going to see it change as we add in more and more variables. So your degrees of freedom and your chi-square is going to go up, but it should not ever become non-significant. So if this goes to non-significance, you got bigger problems. CFI is still doing really quite well. Our TLI is still looking really good too. Our RMSEA is creeping up, but again, it's still, for the most part, behaving depending on what arbitrary cutoff you create for the RMSEA. We still have a pretty good shot that the RMSEA is below 0.05, which is a common cutoff. Our SRMR is 0.023, and that's good. So really everything in this is kind of telling me that we still got a really good fitting model. And I'm going to, again, just begin to check things out. And what you'll notice here is that, whoa, relationship mindfulness, the effect size took a pretty big dive, all right? And so it went from, hovering around 0.40 down to getting cut in half into around 0.23 if you're using your standardized values, or 0.216 for unstandardized. So that might be concerning. You might think, uh-oh, my effect size just got cut in half. There's something going on in my model. My model's wrong. Well, think about the covariates we added. So we were looking at how mindful communication impacts relationship quality, but we're adding in a cognitive process related to the couple. So we added in the RAM, which measures negative attributions. And so what the measure does is it walks couples through some hypothetical scenarios and asks them about how they interpret the other's behavior, right? And so let's say your partner is being cool and distant. To what extent is that a reflection on how that they feel negatively towards you? To what extent is that true in your mind, or something to that effect? And so it's focused kind of on their interpretations of their partner's behavior. And so that's highly relevant to how happy they are in that relationship, right? And so it actually makes a ton of sense that relationship mindfulness, drops substantially when you're adding in a cognitive process that is specifically focused on the relationship. So if this was, education, or if this was something else, then in my effect size dropped that much, I'd be wondering a little bit more about that. And I'd go back and I might look at some correlations. I might remove this from the model altogether, and just look at the effect of education on relationship quality. I would tinker around to see what exactly is going on. But since the covariates that I added make a ton of sense in being highly influential on relationship quality, I'm actually okay with that drop. And what I'm doing is I'm actually saying I actually have a lot more confidence that the relationship between, or the association, I should say, between relationship mindfulness and relationship quality is being further isolated, because I'm accounting for how each partner interprets their other partner's behavior within that relationship. So again, I'm increasing internal validity by adding in these covariates. A full kind of a full explanation to what covariates you should and you shouldn't include is far beyond the purposes of this video. But we're gonna make a lot of assumptions around all of these are appropriate covariates to add into your model. All right. And they're not potential mediators, and we're assuming that there's no untested interactions among them, and all of the things like that. But essentially, again, just from a model building perspective, this is the process that I engage in, because I found it to be helpful. And if errors come up, as they often do in structural equation modeling, I don't have to deconstruct my entire model to figure out where they occur. I know exactly at what step they occur. Because, for example, I might get a non-positive definite matrix, which means that there's matrix inversion problems, which means might be a zero variance on the diagonal, which means there might be some extreme multicollinearity, where adding in these two most recent covariates, that doesn't provide any unique information. So there's a lot of problems that could be going on. Right. So again, that's why we're taking this kind of model building approach. So essentially, that is the idea of model building within the common fate model. All right. So hopefully this has been helpful in helping you understand one of the possible ways to build your model. Again, this is the approach I take in almost all my modeling. So I can get a sense of what's going on within the context of the data. How are they responding to my models? And I want to say one thing really clearly is all of these covariates were theoretically derived. These were not, I'm just adding in variables within my data set just to see what happens. I had theoretical rationales for including all of these covariates. I just added them into the model in a principled way. And again, I wasn't just picking random variables out of the model just to see what would happen, because that's, again, going to lead to type 1 errors, replication problems, and things like that. So hopefully this has been helpful to you in learning more about dyadic data, and hopefully provides some new information about how you can build models, because I often find that we don't talk about model building a whole lot within our coursework. And it's something we just kind of learn through experience. So this is my approach to, again, model building within dyadic data, and hopefully this has been helpful.